I have the privilege to introduce Stefano Moia, one of the PhD researchers at the BCBL, the Basque Center on Cognition, Brain and Language. And he's a very cool guy. I'm sure you will notice the moment he starts talking. And he works with fMRI data mostly, but also with physiological data combined with fMRI data. And that's why we have a few projects on some of the work that he's doing right now. But he's also a massive advocate for open science, especially neuroimaging methods. Maybe you actually have seen the guy before in OHPM or any other open neuroimaging events. He's always playing around with others in this type of events. And yeah, he's going to be talking about actually this, open source tools that we can use in neuroimaging for data acquisition, pre-processing, data analysis, and many, many other things, okay? So I won't steal any more of your time, Stefano. The floor is yours.
Thank you very much, Danny, and thank you for the privilege of having presented me. It's great. It was the best presentation I ever got, so great. All right. Good afternoon, everybody. I'm Stefano, and in the upcoming half hour, or a bit more maybe, we're going to talk about open development and which tools we can use to foster this process. I got perfect connection basically up until 5 minutes ago, obviously. So if there's something wrong with my connection, let me know and be patient. I'm trying to do the best I can here. And yeah, if there's any question, or if you want to chat later after the presentation, we can meet up and see things together. All right, so open development and open development tools. This talk will be concentrated mainly on things that happen normally during a brain hack, and I hope that by the end of it, you will be able to either jump into any project that you've seen yesterday or a project that you want to start today, either during this brain hack or in any other event, or in general during the year, because we don't stop working after Friday. But it should also be easier for you to follow today's tutorial from Taylor and then Echo, because otherwise in Echo we said that we forget too much about him. So, and then Echo. All right, so let's start. Very briefly, just to be on the same page. What do I mean when I talk about open development? When I talk about open development, I mean the idea of developing a scientific tool in an open and public way, sharing it from the beginning of the development, fostering a democratic community of contributors in support of the project, acknowledging all the contributions and the contributors, and using version control and automatic testing. If you're familiar with open source software development, some of these items are there already. Some of these items are familiar to you. Something else I added because it's something that the brain hack community has really worked on and really want to foster and advocate for. And one of these things is the fact that you should see that the development is not just about one tool or project. It's also about the community that you have around it. And we're going to see later why this is an important concept to take into account. And finally, just one thing. I'm going to talk about tool and project as much as I can, because I don't want you to think that this process is only for code and software. It's actually for anything. If you go and look around, you can see open development for games, board games, art. You can see it for documents. You can see for list of rules that communities should follow. You can see it for anything. So pick whatever you want, put it there. If I, by mistake, say code sometime, be patient with me, but I hope I will be able to stay as neutral as I can. So let's start with some jargon then. I said before that doing open development means using version control. And what is version control? Basically, version control is a way to track and manage changes that you make to files. And version control systems are software that do that for you, or better, you can use them to do that. The most popular one, at least in the brain hack community, is Git. You might have heard about it. And you might have heard about it mainly because you heard about us a website called GitHub. If you were at the scavenger hunt yesterday, you used it. If you were not, you missed a huge deal. And I'm sorry for you guys, but you might have still learned about it from browsing the net and looking for cool stuff that were done here and there. And if you thought that Git and GitHub were the same thing, I totally understand you. And I don't blame you, because up until 3 years ago, I thought the same. And then I met a couple of people and started working in a couple of projects and in a couple of brainhacks. And I realized that there's one way that is very clear with which the difference between Git and GitHub becomes apparent. And this example should be it. And it's this. You can think as GitHub as if it was YouTube. YouTube is a website. It's an aggregation website where you can find a lot of videos, and those videos are delivered for you. And the content of YouTube are the videos themselves. And for Git and GitHub is the same thing. GitHub is an aggregation or delivery website in which you can find a lot of repositories that use Git for version control system. It's good to know that Git is not the only version control system out there. Another one quite fairly popular is Mercurial. And GitHub is not the only website that hosts Git-related repositories. For instance, you can use GitLab or Bitbucket or anything else out there. And version control systems are not just in GitHub, Git, Mercurial, GitLab, etc., etc. They can be found a bit everywhere nowadays. For instance, if you check a page in Wikipedia and you check its history, that history is actually a version control system per se. Google Docs has a version control integrated nowadays, and other cloud-based systems like Box or Dropbox or Drive have version control systems as well. So it's not something only related to what we do during a brainhack. It's something that you can implement a bit everywhere. Now, I'm going to explain you the probably most difficult part of this talk. Bear with me. If you manage to get this, in 10 minutes, you're done. You know Git, you know GitHub, you know everything, and you can start with everything, and it will be a breeze for you. So let's see what a classic GitHub workflow looks like. So normally we consider our repository, our project, as a main branch, a main development. We normally call a development branch, and we say that we have some states at which this main development can be tracked. And those states by convention would be those little dots that you see in this picture. And what happens normally is that when we use Git, we tend not to work on the main branch of the main version of our project, of our code. And that's because we want our main version, main development, main branch to be stable, to be usable, to be there and safe. And at the same time, we want to create new features, play a bit with things, but we might have to test out those new features that we want to add without having to break the main version of our project. And that's where we create branches. So we say we branch from main into a new branch that is called, for instance, in this case, dev, in which we do our modifications to the files, and we make some saves. And after making some saves, those saves are not enough for the version control systems to track the modifications. We have to do a step more that is called committing. When we commit a file, when we commit changes, those changes will be saved and tracked. And it's nice because we can always revert to them, and we can have a history of everything that we did during a development. Once we're happy with our changes, what normally happens is that we test them, and if they work, yay, good job. We merge everything back into the main branch, the main development, and we get to a new state, a new commit that contains everything new that we just added. But sometimes what happens is that we don't want to work only on one thing, or maybe we find out that there's something very quick to fix, and we are not that we were not working on before. And maybe we don't want to wait to finish our development of the new feature in order to fix those little things that have to be done. And what happens is that we can branch again, create a new branch. In this case, it's called bug, do some modifications, and put everything back into main by a merge. Now, what happens is that we have a diverging main from what we branched at the beginning. So we have one representation of the code in the dev branch and one representation of the code in the main branch. And sometimes that's not a problem. If there's no conflict, Git will simply merge everything together without any issue, without even bothering you, or without even having you to think about it. But sometimes it happens that you have conflicts because maybe you're touching the same files in the same positions or something similar. So what happens is that you have to resolve those conflicts. So in this case, we merge main into the dev branch. And then again, we can merge the dev branch into main when we solve all those conflicts. All right, I hope it's clear up until now. We're going to complicate things a little bit. Normally, we work in teams. And when we work in teams, we tend to maintain one repository as a stable repository. That repository will be the thing that people see, the thing that people use most of the time. And it's very important for it to be there as safe as possible. So what we tend to do is actually create a perfect copy of that initial repository. We will call the initial repository upstream and the perfect copy origin. And we say, if it's the first time that we're doing this operation, that origin is a fork of upstream. So we fork upstream into origin. So, all right, we created the fork. Again, we branch from the new main branch in our fork, the main origin, into a new branch that is called dev. And this dev will be origin dev. And there we can do all the modifications that we want once again, do all the commits that we want. And once we're happy, we have to send this code back to upstream. What happens here is that we're working in a team. And normally when you work in a team, it's a good idea to have other people check what you did, review it, review your changes, and decide if they're good or not. And in that case, just have a little chat about what can be improved. And that operation, that is actually more a process than just an operation, is called a pull request. And it's what we see here now. But once again, it might happen that two collaborators are working at the same time on the same project, and one of them finish earlier and does some modification to upstream that the other collaborator have to incorporate in its development. So what happens is that while upstream main gets updated, the developer working in origin can take the code from upstream. Every time that we take some code from somewhere else, we say that we pull that code into our branch, our repository. So we pull from upstream the new modification. And again, if there's nothing wrong with them, if there's no conflict, fine, nothing is going to happen. But if there's some conflict, we have to resolve it. And as we were doing before, we have to merge our main branch in origin into the dev branch, fix all the little things that have to be fixed, and then we can go on with our pull request. And I hope it's clear up until now, because I'm going to do a little more complication again. And it's the fact that normally we say, oh, we're working with origin, we're working with upstream. But actually what happens is that upstream and origin are a remote repository. They are on GitHub. And what we normally work on is a local repository. It's some files that are in your computer. And that local version of your repository, it's again a perfect copy of origin, for instance. And it's what Git deals with. And if it's the first time that we're working locally, for instance, if you have a new computer and we want to put up a project there, we say that we clone a repository, a remote repository, for instance, origin, into a local repository. Now, we normally do every commit locally, and then sometimes it can happen that we have to update the code that we have locally. And once again, as I told you before, we take code, so we pull code from, for instance, upstream or origin. But most importantly, since it's a local repository and we want to send code away to our remote repository, we have to push it. We say that we push some code when we want to basically upload it into remote repositories. And everything else is basically the same. So I hope this is clear enough. And if it's not, we can discuss about it a bit more later. But technically, this is a classic GitHub workflow, and most of the projects that you might encounter use it for their development. Now, I said that pull requests are a process. They're not a step. Why? Because they might take a little bit of time. You might see, this is GitHub, by the way. This is a pull request page in GitHub. This is a pull request that I opened toward Feast2Beats, one of the projects we were working on. And you can see that every pull request is not just code, it's also a conversation. And this conversation sometimes can be very long, because even if you change just a couple of files, maybe the changes that you are doing might be improved. And normally this conversation goes on between the author of a PR, of a pull request, and the reviewers of this pull request. Reviewers are other maintainers, other contributors that check what you did and make suggestions in order to improve your changes and get code that is really stable, really fine, with better quality merged in our main development. So take home message number 1 for today: working with Git and GitHub can be challenging, but it lets you work in parallel on the development of new features without disrupting the main version of your project. And as a bonus, it can force teams to double-check projects and changes. And if you ever thought that working with a colleague of yours, you were stopped in developing, for instance, a code or in developing a document because you were waiting for the revision of somebody else or for the changes from somebody else, well, this is your solution. Just go, use Git, use GitHub, and this will not be an issue anymore. All right, so we saw what a GitHub workflow looked like. We saw what a PR is. Now, how do we decide which PR are we doing? How do we decide what is the development? Who is guiding the development? Well, before we say who is guiding this development, I want to talk a little bit about how we can guide this development. And GitHub and any other platform like it give us a couple of very nice tools, very nice instruments. One of those are issues. Issues are basically text, are basically messages that are there in the repository with the code that anyone can open to just say, hey, I tried your code. I think you could implement this little thing here. Or, hey, I was looking at the code yesterday and I found this bug and maybe you have to solve it before we do something else because, it might not be good to have it there. And or any other message like that. And what happens is that sometimes the author of the issue does the job already and then opens a PR and goes on with that. But some other time, somebody else, some other contributor might step up and say, hey, I'm going to do this instead. Or, hey, I think that this person is the best person to tackle this issue. And this issue can be assigned and the person will work on it and etc., what we saw before. And it's interesting to notice that issues and also pull requests can be labeled. Labels are another way to categorize issues and pull requests that we can use in order to make our contributions clearer. And one very nice label that you should know by now, but it's good to have and know in case you see one, is the good first issue label. Because that's normally a label that you will find on issues that are easy to do for newcomers in order for you to get acquainted with the process and the development of a particular repository. And issues can be grouped into milestones. Milestones are basically a list of issues that have to be finished before a certain event happens. This event can be just a release of a new version, for instance, and it can be timeless, or it can be due by a certain date. In this case, December 10, which is incredibly close. So yay. And the nice thing is that you can track the development of all these issues, see them, see what needs to be done, see what the completion is, and know if you will be late for a deadline or not. So take home message number 2, guide the development of your project using issues, milestones, and if you want, labels. It will make your life easier and better organized, and it will make your project easier to understand for third parties. And as I said before, all right, we have this development and we have a way to guide this development, but who's in charge? Who chooses what is the development? what is the governance that we can adopt in a project like this? Well, as I told you before, community is a key point of open development. The community is as much important as the tool itself. And sometimes governance can be in the end of this community. Some other times, governance is in the end of one single person that will be the main developer or a leader that will indicate what happens in the project. And there's pros and cons of these two types of governances. Mainly if you're alone, if there's a leader, the development can be very driven and focused on key points, while if you have a group of people, the development might become a bit more based on the help and the interest of volunteers. So it might not go exactly as you planned at the beginning, but it will get there eventually. If you're alone, obviously decision making is as quick as you making up your mind about things, which for some people can still be long, but normally it's quite easy and quick. While if you're in a group, obviously you might have to discuss about things, you might have to meet and see and track developments, and decision making might take a bit longer than you wanted. And they're right. Up until now, I said things that might make you think that actually going solo is the best way to do things. But there's an important point here, that is this. If you are a single developer, user might not be engaged enough to value your project. If you're in a group, you will automatically create a sense of involvement and responsibility that might increase actually stable contributions and might increase the adoption of your tools. And that's good because honestly, the perfect tool that nobody uses is actually a useless tool. A tool that is okay, but everybody's using and everybody's adopting and everybody's maintaining might actually be much better. One developer also means that it will need more time to integrate new feature, and there will also be a bit less reviewing of what happens in the code or what happens in the project. And that might be not so good. Many developers means less time needed for a new feature because you're multiple people working on multiple features at the same time. And it can also mean better quality because, again, if you go through a review, normally you get an improved quality, an improved pull request, an improved modification. One single developer might also mean less stability in the group because you might have contributors, but unless you're paying those contributors may decide to leave all of a sudden or might not be so interested in the process to stick around for a while. And that means for that single developer that there's a lot time more involved in training new contributors, which might be actually quite challenging. When you have a lot of people working on a project, you have more stable contributors, you have more stable people. That also means that you have more mentors, more people that can teach new newcomers how to contribute. And that will help, and these changes, or in any case, the development of a tool. Now, I talked about these two types of governance, but actually governance, as everything in life, is a continuum, is a spectrum. You might see projects that are a bit more toward community-oriented governance. You might see projects that are more leader-oriented. It's quite common to hear the saying, the position of benevolent dictator. That's basically a leader that takes into account what the community wants, but still leads the development. And that was quite common in recent years. For instance, Python had, up until a little time ago, a benevolent dictator, and other tools had the same. Some other time you might find a repository that, or a project that is in which decisions are taken by a group, but there's a project manager that tries to enforce those decisions in order to make development a bit more regular and stable in time. No matter what your governance style is, no matter what kind of project you have in your hands, you might have contributors and you might have different types of contributions. You might have contribution for code, for infrastructure, for documentation, no matter what. And the thing is that different communities, independently of the type of contribution and independently of the kind of project, might have different requirements or follow different workflows when contributions are done. So depending on the community you're going to join, you might see different things, different rules, or different workflows. How do you know what is the workflow of that specific community. That's why normally in repositories themselves or in documentation related to the repositories, you have something called a contributors guideline. A contributors guideline is literally just a text that will tell you what the community is normally doing. And together with the contributors guideline, you will find a code of conduct that is an important file that people put there because they want development and communities to grow in a stable way, in full respectance of each other. So that's something else to have a look at and consider when you're working with somebody. And no matter what type of contribution you might have, no matter what type of governance, no matter what type of project you have in your hands, it's important to recognize those contributions. And depending on the governance scheme, contributions might be a little bit different and might be recognized a little bit differently, but explicitly writing down how the community does this recognition is essential, and it can help newcomers to join the project. A way that is very open development, open source, open and transparent is recognizing contribution using the all contributors specifications. That is nothing else than a table that associates a little emoji to one type of contribution. So for instance, you have bug, you have business, you have mentoring, financial support, and other things like this. Every type of contribution is recognized. And if you adopt all contributors, you might end up having a little page in your repository that looks like this, that has a little table, a lot of pretty pictures of pretty people that are your contributors, your collaborators, and together with the pictures, you also have an idea of what those people are doing for the project. And this is something important because if you're this transparent, people might be more willing to join because their work will be really there and could be really recognized for what it is. So take home message number 3. There are advantages and disadvantages in any form of governance. Choose yours from the start and state it clearly. And in any case, don't forget to recognize other people's work and take time to develop a community around your tool. All right, some late things. We talked about the community, we talked about the tool and the development and the workflow. Now, what are we missing in order for things to be open, to be public? We miss actually making them open and public. And there's a couple of things that we have to do before that. One of them is testing. Testing that a project works is as important as developing it. And trust me, I'm a person that makes a lot of mistakes during coding and spend a lot of time trying to fix bugs. So arguably, I might even say that testing is more important than doing development, because once you have something that is very well tested, you know that you will not encounter mistakes anymore. So spending time on testing is important, and there are different types of tests that can be done. One type of test is user testing. Normally a person, that can be the user or even the developer, uses the tool with the latest changes that they did and make a report on that tool. So they can check that everything worked out, they can check if there's something else to do or something to improve. And that's a very nice way to help projects, actually. So if you're thinking about helping a project out or helping a developer out, but you're not acquainted with code, just using the tools and making a report, it's a great way to help out. The other kind of tests are automated tests. I think you will see a couple of them later on today. And it's basically tests that the developer themselves write and that will be run after it changes. There are different kinds of automated tests. I'm not gonna be specific about them, but if you have any question about them, we can discuss about them later. All right, we have something tested, it's working, it's great, we want to make it public. What do we need to do? We need to make a release. If you don't make your project public, it will not attract contributors, it will not attract users, it will be a little bit useless. If you want to make your project public, you can create specific fixed versions of your development that represent the changes up until a certain point, and that are called releases. GitHub helps you creating release of code files or in any case projects. And if the project is code related, you can even package this release, and then put it in code archives. For instance, in this case, Fist2Bits is a Python program, a Python software, and we are in PyPy in the archive. So basically what we did is create the release, we create a little package in Python, and people can just use pip to download this package and install Fist2Bits quite easily in their computer. But actually, releasing and packaging is not the only thing you can do, and it's not essential to make your things public. You can also just state somewhere in your repositories or in your documentation and state how people can adopt your tool and use it. For instance, in this case, it's just about cloning the repository locally and then making us adopt. But something that I discovered very recently is that there's a paradox out there. Just because your project is out in the open and can be consulted by everyone, that doesn't mean it's public. Actually, you need a license to make it public. A work that is not licensed, paradoxically, is not really public because you don't know how you can use it. So if you're a maintainer, if you have a project and if you want people to adopt it, take a license, adopt a license. You might be accustomed to licenses are like commercial licenses, like copyright. We have equivalent of that in the open source world. And they're not just for code, there's actually licenses that are open for projects that are not software. But in any case, if you just want to adopt one, there's this website, it's called Choose a License, and you can go there and literally choose a license, so great name, and pick one and put it to your project. And since you're playing the scientific game, you might not just want to put a license to your work. You might also want people to cite the work that you did. And in that case, creating a release is very important because then with this release, you can get an identification number, for instance, a DOI. And Zenodo is a great tool to do that. Zenodo is maintained by CERN. And you can, if you check it, basically you can get your GitHub repositories, sign them up on Zenodo, and Zenodo will track the new releases for you and give you something that people can cite. And one last thing, all the things that I described up until now are honestly quite boring. I was doing them manually for Fist2Bits and PhysioPy in the last year, but I'm a bit lazy when it's about work that is hard and honestly not that fun to do. And I discovered something incredible that are bots and automated workflows. Automated workflows are really your friend. Everything can be automated, from testing to releasing, packaging, and anything else that you can think about. GitHub has a way to implement workflows already. Workflows are basically just a bunch of codes that do things for you every time that a specific event happens. GitHub has actions that you can consult and you can check out and help you creating workflows for these. And they can also be found in the marketplace of GitHub. So maybe you're looking for something, get there and you can find a solution for you and just adopt it. It doesn't even need you to script it. And in any case, GitHub is not the only place where you can do this thing, when you can host your workflows. Other common options are external platforms such as CircleCI, Travis, or Azure pipelines. And all of those are basically hosts for workflows to be run on. And workflows can require a bit of work, especially at the beginning when you set them up. But at the end, in the long run, in the long game, they can save you a lot of time and a lot of mental energy to let you do the work that really matters. So use bots and let them do the hard work for you. Last take-home message of this talk: test and release your work frequently, license it and make it citable, and possibly automate all of these steps. All right, now it's time for me to shut up and it's time for you to do something. And that something can be keep following the tutorials and talks of today's brain hack, but it can also be just jumping into your next project. You have a couple of projects happening already during this brain hack. You have some of them here, and you can consult the website to find more. And trust me, there's nothing better than just jumping in and learning all of these things I just talked about in person, on the job, while doing things and helping people out. So think about it and don't be scared. Just join them. They're friendly people normally, so you will be welcome to give a help and help out each other. And I think that that's all for the moment. I would like to thank you a couple of groups with which I work and I'm part of, the Spin group at the BCBL and the Bright Lab AMI group in Northwestern. But I want to particularly thank the PhysioPy contributors. They're a very good bunch of people that I have the privilege to work on in the last year, and they're actually amazing people, amazing contributors that I really enjoyed working with, and from which I really learned a lot. So a very good other reason to join open development is just meeting new people, learning from them, or doing something together. And one last thanks to you, I hope, for the sustained attention. And all right, time for questions if you have any.